All right, question 30 on the math subject GRE practice test. So I'm starting to suspect that the test makers felt bad after asking 28. Maybe they knew they gave students a question that would take too long, so they made 29 and 30 fairly straightforward. The idea on 30 is we're just going to map the points from 0 to 2 pi onto the coordinate plane by letting the image of one of these numbers get mapped to the point where the x-coordinate is the cosine of that number cubed and the y-coordinate is the sine of that number cubed. You might recognize that if we instead considered maybe f of t that mapped this domain onto the coordinate plane by letting the x-coordinate be the cosine of t and the y-coordinate be the sine of t, we just get the unit circle, right? That's kind of one way you can define the cosine and the sine functions themselves. They're just the x and y coordinate corresponding with angles t measured in the standard position where the angle t is between 0 and 2 pi. So essentially, what happens if you cube the x and y coordinates of all these points? Well, if I look at my different options, I got some nice symmetry going on here. In each of the 5 cases, each of the 4 quadrants are just reflections of each other. So I can really just focus on the first quadrant of any of these different choices. So what are some values between 0 and 2 pi that will get mapped into the first quadrant? Well, I know that if c is equal to 0, since the cosine of 0 is 1 and the sine of 0 is 0, and 1 cubed is 1 and 0 cubed is 0, c of 0 is going to get mapped to 1, 0. I guess that alone allows me to eliminate choice E here, right? Because if this is 1, 1 and this is 1, negative 1, 1, 0 would be right here, and this point is not on the graph. Other low-hanging fruit is that c of pi over 2 would get mapped to 0, 1, and that's because the cosine of pi over 2 is 0 and the sine of pi over 2 is 1. And again, 0 cubed is 0 and 1 cubed is 1. Unfortunately, that doesn't allow me to eliminate any other choices because all 4 of the remaining choices have both 1, 0 and 0, 1 on their graph. So how do these graphs differ? Well, what if instead of considering an angle of 0 and pi over 2, I considered the angle pi over 4? Well, let's see if you have your unit circle memorized. Maybe you know that the cosine of pi over 4 and the sine of pi over 4 are both the same. They're both root 2 over 2. So c of pi over 4 will have that root 2 over 2 cubed as both its x-coordinate and its y-coordinate. What is root 2 over 2 cubed? Well, let's see, without the help of a calculator, I guess I'd have to call that like root 8 over 8. But root 8 is 2 root 2, so it's root 2 over 4. If you know the decimal approximation for root 2, maybe you could ballpark your answer. But assuming you don't, well, we can definitely eliminate answer D, because root 2 over 4 is certainly not 1. And even if we didn't know that we can locate this point by measuring an angle of pi over 4 in the counterclockwise direction from the x-axis, kind of like we do with the unit circle, we could deduce that this point is in the first quadrant because the x and y coordinates are both positive. And then we could also know that those x and y coordinates are equal, so therefore they have to be on this dotted purple line. And the only point on this graph in the first quadrant that's on this dotted purple line is this one with x and y coordinates of 1. So since root 2 over 4 does not equal 1, this can't be my answer. What about the rest of these guys? Well, a cool characteristic that B has, exploiting this circle here, is that the distance from the center to this point right here is exactly 1, right? The radius of this circle. So I suppose we could calculate the distance from the origin to this point, right? Root 2 over 4 comma root 2 over 4. And see if that distance is equal to 1. But you don't have to bother because you already know that the point on the unit circle that's on this line has x and y coordinates of root 2 over 2. So since root 2 over 4 does not equal root 2 over 2, this can't possibly be my answer either. At this point, I could probably just ballpark my answer, taking advantage of the fact that root 2 over 4 is exactly half of root 2 over 2. So I want the point whose x and y coordinates are exactly half of this guy. Even with my poor artistry, I don't know, maybe that would be somewhere in here. I can kind of see that that's not going to be answer A and is instead going to be answer C. These 3 points are not collinear, which means it's not answer A. If you really wanted to prove that, you could find the midpoint of these 2 points, which is somewhere in here. The midpoint formula tells you that the x-coordinate of the midpoint is just the average of the 2 x-coordinates, so 1/2 in this case. And the y-coordinate of the midpoint is the average of the 2 y-coordinates, so it's also 1/2 in this case. And since root 2 over 4 does not equal 1/2, A is not the answer. By process of elimination, I know that C must be my answer. I'm done with question 30. For the purpose of a learning video, it's good to kind of talk through why all these other answers can't possibly be the answer. But for the sake of a timed test, If you know that root 2 over 2 is like 0.7 or so, either because you have that memorized or because the square root of 2 is roughly 1.4, and that's because 1.4 times 1.4 is 1.96, or 14 squared is 196. Anyways, because 14 squared is 196, 1.4 squared is 1.96, which is damn near 2. Therefore, the square root of 2 is damn near 1.4, so the square root of 2 over 2 is damn near 0.7. Why is this relevant? Because we can ballpark 0.7 cubed pretty easily. All right, 7 times 7 is 49, which is almost 50. 7 times 50 is 350. What I'm saying is 0.7 cubed is at 350 if I move the decimal place 3 spots to the left. In other words, it's more or less 0.35. I think it's 0.343 if you actually go through and do the math. Way back at this stage, if we knew the x and y coordinates were 0.35, we could just draw our first quadrant maybe a little bit bigger. If this is 1 and this is 1, then 0.35 is like right here. So the point with coordinate 0.35, 0.35 is roughly here. Just by looking at these 3 dots, we know that our answer is C. Probably other ways that you could have come up with this answer, but this feels like enough time to devote to this problem, so I'm gonna call this good.